Hello everyone. Thanks for joining us today for the webinar. My name is Subra Kumaraswamy. Today I'll be talking about Agile API security. It's one of my favorite topics. This presentation will be available after this presentation. We will be posting it in SlideShare as well as YouTube. There are a variety of other interesting presentations you should take a look at, including some interesting topics around OAuth and other security aspects, including API design and architecture. Okay, so my name is Subra Kumaraswamy. I am the head of digital security at Apigee. You can follow me at @SubraK on Twitter. At the end of this presentation, please post your questions. And if you want to find me after that, you can also send me a direct Twitter message. So today, we're going to talk about the methodology by which you can achieve Agile API security. I'll talk about why it matters, especially in the current context of the high threat profile environment as well as high demand to achieve innovation. And we'll talk about some of the enablers. There are 5 key enablers and approaches you can practice. Whether you are in an on-prem situation or in cloud, these are applicable across. And we'll wrap it up with the key takeaways and summary, and then I will be glad to answer any questions you may have. Okay, let's start with why Agile security matters, right? Whether it is API security or mobile security or cloud security, there is a need to make sure that we can deliver Agile services to the business and to the developers. To set the context here, there are 2 forces acting up. One is the need to innovate faster. Developers are constantly challenged to come up with new features driven by business. Business is trying to create constant differentiation, hence innovation is a way to go. And developers, as you know, they love to play with new platforms. You got a language coming up every other month or so to speak. The most recent one being Node.js, which has a huge adoption. And there are a variety of other languages out there that developers live and die, and platforms. If you go to a Silicon Valley startup here, and you look at the technologies they use, you're going to see a variety of acronyms and including some of the things I mentioned here, PHP, Ruby on Rails, Angular, and so forth. So developers, are pushing those platforms, and it's really to help innovation. On the other end of the spectrum, we have the security risks, and as we saw in the last year, there were quite a few breaches. The most notable one being Sony, and of course, in every breach is different, and these breaches are going to happen. We'll see more of them this year, for example. One example I want to highlight here is the Moonpig. Moonpig is a retailer out of Europe, and they had an API breach because it wasn't designed with proper authorization in place. Interestingly, they had a good authentication in place, but because there was no proper authorization, anyone who was authenticated was able to see every other person's information. So that resulted in PII exposure, and that's an example of a breach where we could have prevented. And the most recently we saw the Ghost vulnerability. This is the one that on glibc, and if you haven't patched it, please make sure you patch every of Linux systems with the Ghost patch. And what it does is that if you don't have an agile security approach, there's going to be a constant reaction as well as not able to support the innovation that the developers are demanding. Now let's talk about who are the stakeholders when it comes to delivering an API product. Right? We in Apigee like to call API as a product, and I'll talk a little bit more about why, and in fact why it matters from a security standpoint. So API products or API services are delivered concerted fashion and in collaboration with the product manager, the business owner, the operations or managing the infrastructure, and the app developer who's actually developing the app. And each of these folks are interested to make, and they have an interest to make sure that they can delight the end users with the user experience and features. At the same time, there's also interest to make sure that we do it in a secure way. For example, the product managers, they always want to know how you can reduce the delivery cycle, how fast you can deliver a feature. In my previous company, eBay, the CTO used to say that he would like to dream of a feature on Monday, and by end of Friday, he'd like to see that feature developed as a prototype or pushed to production. So the innovation cycle is really, really fast. So while product managers are trying to compress the release cycle, the business owners are trying to expand the product surface. They want to expand the API program. Usually API programs start in a small business, in a small side of the business, and then as they get the taste of success, they want to expand the API program into a platform across the entire business. And they want to do that in a way that it didn't put the company at risk. At the same time, also be able to meet compliance requirements. Compliance could be for PCI, HIPAA reasons, or if you're a European company, you have the European Data Security Initiative. You want to make sure that the data that you're exposing through API is secure. So the business owners really, really want to make sure that they don't put the company at risk. And then if you look at the other side, meaning the guys who are delivering those features and managing them, ops, I should rather say DevOps. DevOps is a new culture where the developers are empowered to do a lot of the operations, and it's done through automation. And the DevOps folks are very interested to understand what options they have in this new world of cloud and mobile, and sometimes hybrid clouds, be able to protect those applications and services using new tools. For example, if ops are used to some of the traditional ways of managing the security for infrastructure, and they always are looking for ways to protect, with respect to embedding security into the product. And if ops is being delivering this through traditional tools in the on-prem, now they may have an option to do this through cloud. Similarly, the app developers are looking at ways to enable security, build security into the product without really coding security into everything they do. Actually I want to emphasize that point. Unless you provide an option for developers to make it easier and make it more of a configurable, developers will end up writing a new module or duplicating security features across the products, and that's a really bad. It's a really bad behavior, and it may introduce new vulnerabilities. So the key is to create a reusable set of configuration and policies that can be applied across the developer, the developer functions, so we can make sure that the attack surface is limited. The other aspect is, as you know, there is a lot more demand from customers to make sure that they can use a product without much friction. So which means like you're enabling new type of features like social logins, and you want to make sure that the product can support these kind of features without making it onerous for the users. Now, if you look at how security has been done over the last decade, a lot of the companies are built, I would say, building a Fort Knox, where you're providing a lot of security, for different reasons. It's not a bad thing, right? You want to make sure that you have a strategy and approach which calls for defense in depth. So there is, layered security across the ISO layers. For example, you may have a DLP, a data leak prevention product, that's making sure that you can inspect traffic going out of your enterprise networks. You might have invested in DDoS protection to make sure that you can protect you from any kind of DDoS attacks on both on the cloud as well as on-prem. And on the software security side, I'm sure you're invested in some kind of static analysis tool or dynamic analysis tools. And again, these layers are very important. and it does serve a purpose. But the question is this good enough? Is this going to help you as your enterprise or your business is moving to the digital world and pushing the innovation for mobile applications, cloud applications, or all, and including the latest IoT requirements, where you're seeing constant connectivity between devices and the services. Do we have the right approach to not only make sure that we can support innovation, but also like to make sure it is secure and making sure that we can respond to any kind of breaches. So obviously, one of the key requirements is that security by itself does not serve the purpose. It has to be a way to enable the business, enable the DevOps and your developers, and be flexible enough to meet the new requirements around fast iteration. So again, making sure that you can enable the product managers to compress the cycles, as well as enabling the business who are expanding the API programs or your customer-facing programs using mobile applications. So now we'll talk about the new approach. And this is the one. I guess the crux of this presentation is what do we need to think about? And I'm going to talk about an approach that can be practiced in the context of API. And this is something that I feel very passionate about, because the fact that security is not simply an enabler of compliance, it should be an enabler of innovation. So there are 5 key things I'd like to walk you through. And throughout this presentation, I'm going to be referencing these 5 functions or aspects of Agile API security. The first one being the Agile, having an API first architecture with built-in security. And I'll talk about why it is, we'll go into the details of that. Like any product engineer, I would always start with the architecture, understand, what we are solving for, and having a proper architecture design to support development. That followed by the secure and agile SDLC, software development lifecycle. And why that is important is that unless you can enable the developers and DevOps during the product development lifecycle in a way that you can release the product features from cradle to grave, right? From going from dev test to prod, you're going to have a constant reaction and not be able to support the faster innovation cycle. So we're calling the embedded security processes in the software development lifecycle. And the third one being the how do you securely expose the APIs? And this is really targeted towards the API team who are exposing the APIs to the consumers who are typically a developer or partner or who are embedding a mobile applications in the platform. The fourth one being the consumption layer. How do you make sure that the mobile applications, your partner applications, they can consume those API in a secure way? We'll talk about authentication, authorization aspects for that particular approach. And the last one being data security governance. Really, at the end of the day, you want to make sure that the data that is shared, exposed from the API to the applications are secured and be able to protect the data at all from data in transit to data at rest. So let's start diving into the first one. The first domain being the API first architecture. Why this is important is that unless you can have a approach where you can separate the concerns, you want to separate the concerns of the consumption tier from the API exposure tier. Unless you can separate that, you won't be able to design and architect the right level of security into each of those layers. Hence, we'll talk about the security options, security controls for the exposure layer, followed by the consumption layer. The layer in the middle here, which shows the mediation, the API tier, is really your API management platform. For example, if you're using Apigee Edge, and that's your platform that allows you to mediate the traffic between the consumer apps and the APIs, be able to apply the policies, security policies, And I'll talk more about that, including threat protection policies and traffic management policies like CODAS and spike arrest. So the API tier layer kind of acts as the facade on top of your API services and provides a nice and clean way of segregation between the consumption tier and the exposure tier. So this is something that, if you're starting today, unless you're having an API first architecture and be able to make sure that you can put the right level of security for each of those layers, you will have difficulty in scaling yourself. And it's a very important concept, and be able to have a strong foundation as you start expanding your API programs into a platform. Okay, so now let's look at the typical API security architecture. Now this is a layer, the layer I'm showing, the box I'm showing here really is the API tier layer, which is the layer that is managing the orchestration of APIs and be able to mediate all the requests coming in from your applications. And as you see in this diagram, there are multiple folks who are multiple users interacting with this platform. You got the developers, the developers who are really writing apps and who need the right level of access to the API. And I'll talk a little bit more about different type of developers and why it matters. And then and the developers need to be onboarded, from the point of giving them an API key to be able to deprovision them when they're no longer part of the program. So there's a whole API developer lifecycle management that you need to think about. And similarly, on the exposure side, you have the API team. Really, this is the team that is designing APIs and allowing the developers to consume the APIs. So they both are, interacting with this platform, and you want to make sure that you can provide the right level of security, so such that in a way that each of them can be productive and be able to make sure that they can create a secure environment. For example, you don't want to you want to make sure that the developers can be differentiated in a way you can differentiate the internal developers from, meaning your employees or vetted developers from a third-party developer who's coming in through your developer program. And you have to have the layer that I'm showing on top here. It allows you to provide the right level of authentication, authorization, and be able to manage the keys and tokens. And again, if you're operating this in a multi-tenant environment like we do here, those should be able to support the isolation of the keys and tokens from the developers as well as from the API team. So the top layer is important to manage your platform, right? This is the management layer, and typically that involves integrating with your backend services like your Active Directory. If you have an IND provider that supports SAML, you should be able to enable single sign-on for authentication as well as for a really good user experience. So the layer allows you to kind of enable and all the access control aligned with your corporate requirements. The layer below that, which is the API security, that's the runtime environment, right? So the separation between the management tier and runtime tier is important. API security tier really is enforcing all the policies that are designed by the IT security or API team, which I talked about early on. And those policies are, it has to be consistent across your APIs. And that's part of the big, once you create an API security policy, such as protecting against attacks like threat, DDoS, SQL injection, JSON injection, and so forth, it can be applied across all the products, API products. So you don't have to go and recreate them over and over. Be able to do the logging and auditing. Every activity that the developer or IT team or API team interacts should be logged and audited. Especially if you have a security information event management system like Splunk or Sumo Logic, you may, or your custom backend, it allows you to kind of enable intrusion management. The layer below, the threat protection layer, I'll talk a little bit more on the future slides, but the idea is that the threat protection, whatever you do, whether it is enabling secure handshake between apps and the API through two-way SSL, or be able to enforce quotas and be able to limit the traffic based on the type of developers, you want to have that as a policy layer that spans the entire platform and protects all API, right? This way you're not out there recreating the policies over and over. And lastly, you want to do that in a way that the platform enables you to be compliant. You may have requirements to comply with PCI HIPAA, and you don't have to, you shouldn't be going out of the way or doing additional work. It should come with part of enabling security features. And as you're looking at this end to end, one of the key requirement is making sure that the identity and access control is enabled at every interaction. The user has a requirement to make sure that user can leverage or use their own identity, whether it is a corporate identity or social login, and be able to do that across all the services. So user may come through on a Facebook login or a Google ID, and that might give you a different kind of service versus coming through a corporate user ID and credential. Application has a need to authenticate and make sure that you can authenticate the application using an API key, as well as be able to enforce the type of traffic the app can inject into the API. The app developers are, again, I mentioned as early on, there's a need for an app developers to be onboarded with single sign-on. You may be using an existing single sign-on that is already in place, and be able to authorize the developers based on the type of developers. And then the API platform itself, has a need to authenticate against the API services in the backend. So typically that's accomplished through two-way SSL and so forth. Key message here is that for every entity that is part of your API ecosystem or the value chain, you have to map out the requirements for authentication, authorization, and auditing, and to include your corporate requirements around single sign-on or other type of authorization that allows the your enterprise to be compliant with the internal standards and as well as compliance. Okay, so now that we discussed the architecture, let's talk about the second function that enables agile API security. And this is again something that will enable both the developers and DevOps, and I'll talk a little bit about the methodology here. A typical SDLC, and this is in a traditional method we call the waterfall. If you look at how it's done, you have a product initially starts with a design, and the security architects are part of the design discussion and be able to influence the design requirements. And more importantly, every product that is being delivered, web product or API product, has to be threat modeled. The threat modeling is a really, really important exercise that everyone should go through. And the reason is that unless you can actually threat model with the right actors, the actors could be your internal developer, your external developer, your partner, the type of APIs you're exposing, the data sensitivity, all that is taken into consideration. The threat model provides you the interfaces between each of those actors and the security controls that should be baked into each of those interaction. For example, an external developer may be required to do two-factor authentication, whereas an internal developer may be required to sign in through a corporate Active Directory login. So if those are the type of controls you have, and also looking at what threats you're mitigating against, you may be mitigating against a phishing attack or mitigating against a DDoS attack. So those, for every interaction, the threat model provides you the visibility of the attack surface and be able to inject the right level of security controls. And usually, in agile development lifecycle, right, where developers are constantly iterating and releasing features constantly, this is very API product centric. And I say API product is a way of grouping APIs and be able to associate that with a particular API key. I'll talk more about that. So by aligning yourself with an API product, you don't have to do threat model every time. You just do it for once at the time of the very beginning of the API product design. And then you're, at that point, you already understand what security requirements you have, as well as what security controls you need to embed. So that is done at the very first phase, followed by, secure coding practices. And these are, typically your code reviews, and you would probably have a static code analysis. There are a bunch of tools out there. And, most companies are probably, using a combination of static code analysis tools as well as dynamic testing tools. Not necessarily all the tools are API centric. So something you may want to look at is your tool capable of supporting API testing? So having these two tools is simply is enabling your product to be more secure and hardened. But the most important thing that will enable agility is when you start automating it, right? So you want to integrate that into your, if you have a CI, a continuous integration process, you want to integrate these tools so that you can you don't have to be part of every agile processes or every agile teams. The tools are performing at the end of the day, as the build is done using a Maven and Jenkins. You can trigger static code analysis checks, and from that point, developers are sent information about vulnerabilities and what they need to fix. And usually, it is prioritized so that way you don't have to look at every single vulnerability and you make sure that everything is mitigated. You may want to start with the critical and high first for the first iteration, and then before going live, you may want to mitigate medium and so on and so forth. Again, the message here is that you want to focus on automation. And lastly, the verification process. And this is again, although you may have security engineers and developers with security mindset, it's very important to have a third-party testing as part of the program. And you can enable, we can engage with a third party who can do a pen testing, either a black box or white box type testing. Typically, that's done once major release, and if you have a release every once a year, it's typically done once a year, or if you're doing it twice a year, you align with that. And then be able to monitor that. Monitoring is done again with some tools out there, like White Hat Security, for example, allows you to look at your APIs and what is changing and alert if there are vulnerabilities like cross-site scripting attacks. If you have any kind of a token compromises and so forth. So as I mentioned earlier on, it's very important to ask the right questions before you venture into API program. And first thing you want to look at is what categories of developers and applications you have. This will help you answer the type of threats you're protecting against. If you're internal developers, the requirements for access control is going to be very different from partners and the public developers. And the tools available to secure will be different. So by making sure that you can answer these questions, you can actually come up with a threat model as well as the security controls that allows you to secure those apps. And as I mentioned, data, it's very important to understand what kind of data you're exposing. A lot of the companies start with non-sensitive data and to experiment with API programs, and then move on to exposing sensitive data. So unless you can have a process by which you understand what data is being exposed, you may overlook some of the controls required, like encryption, hashing, key management. So by making sure that every API product, you have the right, by asking the right questions at the design phase, you can mitigate a lot of the risks and embed security early in the process. there's a saying that the cost of response is 100 times the cost of prevention. So the earlier you can actually inspect and be able to embed security, the better you are. And when it comes to API threats, again, as part of threat modeling, you're going to look at the threats, and specifically you're going to ask, how is the API threat different from a traditional web security threat? So in this slide, as you can see, there are a bunch of these things that you typically consider as part of the threat modeling, but I want to emphasize the ones on the orange, and these are the ones that are very specific to APIs. For example, the most recent some of the breaches were the result of API keys getting exposed, either inadvertently because the developers accidentally checked the API key into GitHub, or because the API key was decompiled by the hacker. The app itself was not properly securing the API key, so you expose API keys. And once the API key is exposed, the hackers would be able to use that in different ways and pilferage your data. So the other aspect is that how is there any kind of a privilege escalation that you need to think about? If you don't give the right level of access to the developers, again, you may expose more than what you should from API standpoint. So be able to look at each of these threat and be able to say, hey, does this threat matter for my particular API program? If I'm exposing APIs to my internal developers, I may have a need to make sure that I can secure the access control using authentication authorization, using my internal security services, versus if I'm exposing to an external developer, I may have to think about providing the right, the vetting process, as well as making sure the keys that are provisioned to the API developers are more, fine granular, so they get limited access to the packets. So far we discussed two aspects. The architecture, having API first architecture enables you to build a strong foundation. Having a good, solid, agile SDLC process allows you to iterate faster. Now we'll talk about what security controls and features that you need for secure API exposure. So if you look at a typical API platform deployment, you got the apps on the one side, which are actually consuming APIs, and they're interacting with the gateway like Apache Edge. And the edge is protecting the API services, and want to make sure that these services are exposed in a secure way to the developers. So what are the things you have to think about from exposure standpoint? And typically these exposure is done by the API team, and the API team are using a management API or an API console to configure them. First is making sure that the backend services, like your APIs, are able to either do secure authentication like OAuth, and if you're not doing OAuth, probably you want to at least do TLS, where you can actually authenticate using a two-way authentication between the API gateway as well as your backend. This allows you to make sure only the platform is connecting in a secure, in an authenticated way to your API services. And in some cases, your API services may be supporting, a SAML-based or WS security, or basic auth. For each of those, you have to make sure that the API platform can orchestrate with the right level of authentication authorization. And with respect to the API team itself, every API team members will be given a role. So having an RBAC system that supports privilege management for different type of API team members is important. So for example, you may have some members just deploying APIs and not necessarily be able to go and do troubleshooting. If you're a support team, you probably want to do some auditing and troubleshooting, but not necessarily be able to modify the APIs, meaning the API configurations. And if you're in a business team, you're interested in the analytics, as well as some aspect of abuse to understand is there an API abuse going on. So having these features enabled and done mostly through configuration is important. Like I said early on, it's very easy to code, but but when you enable configuration, you can provide consistency and be able to reuse across the products. So again, the slides will be available for you to use it as a guidance. These are the type of features that you want to make sure that you have, and FPGA platform supports that today. For example, be able to support integrating with your enterprise IND services. Could be an AD, could be third-party services, could be a OpenID Connect service, for example. Could be your internal custom services. And similarly for the API developers, you want to make sure that you can onboard the developers using single sign-on, be able to differentiate developers using RBAC, and then there are features like data masking. These are very important to obfuscate and anonymize sensitive data like credit card data or PI data, and so that in a way that it is not visible to any developers or API team, as well as not visible in the log files. And having analytics is important for, like I said, across board for both business as well as for IT security folks. For example, you may want to know which IP addresses are generating a lot more traffic, and if you see a spike, that could be because either it's a legitimate use or you have a key exposure and the keys are being abused, and you see a spike in traffic from a specific set of IP addresses. And lastly, the governance and compliance, right? Like I said, by creating a policy template that is reusable, you can actually enforce consistent policies and be able to meet your compliance requirements. Now that we addressed the architecture, the agile security processes, and then securely exposing your API, let's talk about the consumption tier. This is the tier that's authenticating with your API gateway, and typically your mobile apps, your partner apps, could be a third-party web app. The key here is that you want to make sure both the developers and apps who are using those API services are protected, and this can be done through SSL, from making sure that the apps can only communicate to the backend through two-way SSL, as an example. Be able to do threat protection. The threat protection here is again based on the type of developers, the type of apps. You may have a privilege that allows the internal developers to access all of your backend APIs versus limiting the scope to a certain number of developers. And this is typically done through protocols like OAuth. OAuth allows you to create more fine granular authorization, so that you can say, developer A who's trusted can get unlimited access to your backend with an unlimited scope, versus the developer B who's untrusted developer and needs to come in through specific authentication and with OAuth and limited to certain scopes like read only. So again, let's look at a checklist here for the consumption tier. Now each of these checklist items are actually a policy that is part of the platform. By making sure that you enable these policies, you're able to enforce security in a way that it's reusable across all the products. For example, quota enforcement. If you know that a particular API key is limited to a certain number of API calls per day, you can limit that by putting a policy for each of the API products. Let's talk a little bit about the threat protection layer. There are quite a few threats, low-hanging fruit, so to speak, that is usually exploited. One being SQL injection. This is a typical attack on a web application, is also applicable for APIs, as well as the cross-site scripting attacks. These can be prevented again by having a very simple policy, and if time permits, we'll do a demo today. If not, we'll follow through with another session. We'll go deep dive for each of those security controls. By having a policy template for consumption tier and exposure tier, you're able to enforce security without really going in reinventing the process, or reinventing the vetting process for every API launch. So we'll talk about the data security, and this is a part that is very important and allows you to be really agile. And we'll dive into the details in a second. So API products is actually a way to provide interface into your platform using a collection of APIs. It's a way of grouping APIs and be able to associate that grouping to an API key. So this allows you to really provide a fine granular access control. For example, as shown here, there are three different API products, A, B, and C. You can create a mixture of resources. The resources are really your API services, and each of those resources can be exposed in a way that it suits the product. For example, if you're exposing a payment API, right? A payment API may have an option to verify credit cards, and a payment API may have a API to update a credit card, but not necessarily you have to expose both the calls on the same product. So you may have an API product that allows you to only allow for verification and maybe verifying the shipping address, versus a product that allows you to update credit cards or update the user information. And these two products will be exposed to the developers based on the privileges. So an internal developer may have access to an API product that allows you to update the payment details, versus an external developer will be able to access the API product for only verifying the credit cards. And usually this is done in combination with the OAuth scope. And again, the OAuth scope is a very, very powerful feature that allows you to manage the authorization of the APIs, while making sure that you're exposing the right level of API services through API products. You have to make sure that the data that is sent in the payload, especially if you are sending sensitive data like your credit card data or payment data, PII data, you need to have sufficient level of encryption hashing. Sometimes it is not possible to do that end to end. So that's where the API management platform comes into the picture, where it can mediate. So for example, RPGH, you can store credentials in a secure way and be able to mediate that with your backend. So you don't have to embed that into the apps. The lastly here is that you want to make sure that the data sensitivity is taken into consideration. So by creating an API product that is PCI based, let's say calling it as a PCI product or payment product, it allows you to iterate in a faster way when it comes to SDLC. So you may not necessarily have to perform every single SDLC activity for a non-PCI data, as just an example, versus you may have much tighter controls and much stricter enforcement when it comes to authentication authorization aspects. So finally, let's just want to summarize how you can improve the agility in your API services and delivering API products. The first is making sure that you have a strong API architecture, API first architecture that allows you to separate the concerns between consumption tier and the exposure tier. The key is that the consumption tier needs a flexibility for authentication. It could be coming through a social login, through an OpenID Connect, through a corporate identity, versus exposure tier, it's always consistent. You're probably authenticating and authorizing against your backend like Active Directory or a single sign-on service. So having an API first architecture allows you to support those kind of requirements. The second one being having a SDLC that's automated with your internal development processes. Use of Jenkins and Maven as an example allows you to iterate in a faster fashion, taking into consideration the threat model, so that you know that some API services will require maybe a longer cycle because it's exposing sensitive data versus the ones that are more experimental. The third one being be able to centralize the API security for consistent policy enforcement. This is the exposure tier. By centralizing your authentication, authorization, and auditing, you're really creating an environment to have a consistent policy enforcement, and that way developers are not recreating the policies for every single product. The fourth one being be able to have a standard way for the applications to authenticate. For example, OAuth is a preferred methodology, a preferred mechanism. By having a standard way of authenticating the apps, you are mitigating threats such as privilege escalation, key exposure, and so forth. The last one being having a data-centric approach where you're clubbing services into API products, and those products are categorized based on the risks. Like for example, higher sensitivity data like payments could be in a separate product. So by practicing this five, again having a architecture, design, policy, reusable enforcement, you can actually compress your development cycles from months to weeks, and at the same time, be able to reduce the attack surface and meet your compliance requirements. So again, thank you for joining us today, and we'll be happy to answer any questions you may have. Okay, the first one being from Manish. How easily configurable for OAuth 2.0 and SAML? In fact, it's very, very straightforward. Our product supports OAuth 2.0, OAuth 1.0a. It's a drag and drop. You can create endpoints like /authorize /access tokens. And again, we support all the 4 grant types. In fact, if you go to rpg.com, there's a tutorial on all the different grant types we support. For SAML, we do have a SAML assertion support which is again a policy based. We currently integrate with a variety of third-party services that supports SAML 2.0. What are some of the mitigation techniques to prevent scraping? So it's a very good question. Just to expand on the scraping, there are certain type of bots. These are bots, not the malware bots, right? These are API bots that are automated to go and screen scrape through APIs. It's a very difficult problem, but one of the things we are doing is we are in the process of creating anomaly-based API behavior detection techniques. It's going to require you to do a combination of looking at your logs as well as looking at the API transactions, and then doing even correlation to understand what's normal behavior versus abnormal behavior. So we are actually working on a product that allows you to do that, and we'll be giving more details in future. There's a question on what is TLS. TLS stands for Transport Layer Security. It's a replacement of SSL. As you know, SSL 3.0 and SSL 2.0 are almost outdated, and you shouldn't be using it. And TLS is a standard way of communicating between an app and API. It's a transport layer security. Could you recommend any good static analyzers for API? Just to kind of just to expand on this question, static analyzers are the tools that are the static code analysis tools used by developers. There are tools like check marks that allow you to scan your source code and look at vulnerabilities. Most of the tools are generic tools, but they're good enough at this point. I would say if you invest more on dynamic analysis, you get more bang for the buck, because dynamic tools are much better at finding API vulnerabilities. For example, the open source like Burp Suite allows you to test APIs. Okay, there's a question here. What type of security approaches can be taken for real-time applications where lower latency is a primary concern. The biggest thing I would say is that to looking at your rate limit policies, to make sure that if you know that the particular applications are using like a WebSocket as example, and if the application is if the IoT or a client is going to connect longer and keep your sessions open, having a policy that allows you to manage that, so you know that it is not a attack versus a real legitimate client which is holding session for a longer period. Okay, do you have any thoughts on the best way to implement real-time API? So I'm presuming this is a question in general. Yes, there are features like WebSockets that allows you to do that. Again, the methodology by which you're securing the API, that should remain the same. Making sure that you have the right level of policy enforcement to handle both incoming and outgoing connections. Okay, will recording of this be shared? I joined 10 minutes late. Yes, of course. This will be published in a week or so in YouTube, and we'll be sending out the details. Okay, tips on handling record level authentication. That is, keeping app A from seeing app B's data. And this is done, as I mentioned early on, the API products where you are actually marrying the URIs with the verb, like get, post, put, delete, and be able to exposing the right level of records through that construct, and in combination with OAuth scope, right? So this way you have an app A with a specific key. The key is assigned to an API product, and the API product allows you to expose only the right level of records using the URI and verb constructs. There could be other methods, but that's the easiest way. Do you have a time to demo the process? So we will have a separate session focusing on a deep dive to do a demo of attacks, including rate limiting and CODAS, JSON injection, and so forth. Unfortunately, running out of time today. What solutions do you offer on-prem and cloud? How do you mitigate DDoS? So we offer both on-prem as well as cloud. Our features are in parity on both sides. How do you mitigate DDoS? We do that using a combination of infrastructure security from a cloud standpoint, as well as using API policies such as rate limiting and CODAS. Is there a recommendation balance between difficulty in consumption and security requirements, like hashing and encryption being difficult, costly for a web mobile, but want to do a PCI compliant? Yes, certainly, like I mentioned early on, the consumption tier, you have to manage it through the API keys, and you can leave the hashing and encryption of, you can relegate that to the API platform, API gateway like Edge, especially if there is a concern around storing sensitive data in the mobile devices and apps. All right, folks, I think we are out of time. Thanks for joining again. We will be posting the slides in the YouTube and SlideShare, as well as if you have any further questions, please send a tweet, and we'll do our best to respond. Thank you.